Okay, welcome to Lesson 9, Descriptive Statistics. Here's the statistics that you'll need to know. Most of them you probably know, but we're going to go through them and explain how they work. But these are the definitions. Okay? So you might want to look at those things. One of the more important ones here is going to be standard deviation, which is the average distance from the mean. It's kind of like the one that you need to understand, and then to even move further in statistics, that's the key one for understanding. These other ones you probably have seen before, but we're going to go over them. Okay, let's look at these descriptive statistics. For one, we're going to organize the data from largest to smallest. So the data we have is the age of students in the classroom. So the reason we do this is because there's statistics like the median in which you really need to have the data organized in order to find it. Now we're going to do this by hand, and we're also going to do it with Excel. Excel has these built-in functions here which will do it automatically, and we'll go through that after we do it by hand. But let's put up our hand calculations here. And so the smallest number is 17 years old. And then I have one 18, two at 19, one at 22, one at 23, one at 32, and one at 54. So that is from smallest to largest. It's really easy to do with Excel. You just use the sort function and it does it automatically, but we'll get to that after we do these. Now count just means how many are in the data set. And so we'll just count them. 1, 2, 3, 4, 5, 6, 7, 8. The count is 8 because there's 8 in the data set. The mean you know probably as the average, and in Excel it's actually called the average. But what it is, it's the sum, and this symbol here means sum. The sum of the x sub I, which means the sum of all the data, divided by n, which is often used for the count. So the sum of all data divided by the count, you know this, it's 17 plus 18 plus 19, etc., divided by 8. And you put that on your calculator, and you should get 25.5, I believe. Now the median is the one in the middle. So the middle of this one has actually 2 in the middle, 19 and 22. Those are 2 in the middle. So when you have 2 in the middle, what you do is find the average between the two. So that's 19 plus 22 divided by 2, which would give us 41 divided by 2, which is 20.5. The mode is the one that occurs most frequently. So in this data set, the one that occurs most frequently is 19. It occurs twice, and none of the others occur but once. The maximum is simply the highest data value in the set, which in this case is 54. The minimum is the smallest value in the data set. In this case, it's 17. The range is simply the max minus the min. Put that up there a little bit, which would be 54 minus 17, which should equal 37. The standard deviation is going to be a mess to calculate with this. So we're going to dive into that with a smaller data set and explain what it means. So this is how you do it by hand, and now I'm going to switch over and do it with Excel. Okay, so here's our original data set, and I want to sort this from smallest to largest. So I'm going to highlight the data set, and if you look up here in the top right, it says sort and filter. I'm going to click on that. I'm going to go from smallest to largest, and you see it sorted it. Now for the count, and I didn't really have to sort it in order to do these functions, but sometimes you'll want it sorted. The count is a built-in function, so it's just equal count, and you can click on it, double click, left double click, and it gives the first parenthesis, and then you can highlight the set, which is G3 to G10, close the parentheses and hit enter. Mean is just equals the average, and you can start typing and you'll see average right there. So I'm going to double click, left double click, and I want the average of all these numbers, and that's what I mean by cell A to cell B with the colon. The median is equals the median. Again, it's a built-in function. The mode is also a built-in function. And what if you do this? What if I go a couple past that? Think it'll matter? Think it'll say 0 is the mode as well as 19, two modes? And the answer is no. If blank cells, it just totally ignores them as if they don't exist. The max is just equals the max of that data set. And the min is the minimum of that data set. And finally the range, and this is what I'd say, equals the max minus the min. So that cell minus that cell. Now the standard deviation is, I'm going to say, equals STDEV right there of this data set. So the standard deviation is 12.46. So it might not be that much easier to do it with Excel, but when you have a data set of hundreds, it's certainly a lot easier. And the other thing, this standard deviation would have been a bear to calculate with these numbers. Okay. Okay. So I thought I better show up to help you with this one so you didn't feel alone. So I'm here just to lend my presence. All right, standard deviation. We're going to try to understand what it means. We're going to go through it, right? So we have two data sets here. They both have the same average. So let's just find the average here. We know they're the same, so we'll leave it at that. So the way we find the average is 2 plus 2 plus 4 plus 6 plus 6 divided by 5. So that's 10, 18, 20 divided by 5 is 4. So that has an average of 4. And these are just showing 2. These are sort of visual representation of the data set. Over here, it's pretty simple to find, right? Because this is 1 below 4, that's 1 above 4. They kind of cancel, so the average is 4. So both these data sets, data set 1 and data set 2, have an average of 4. So now let's look at the first question. The mean represents what value is expected from the entire data set. it can be looked at as representing the fair value of that data set. So 4 is the fair value of data set 1, and 4 is the fair value of data set 2. For which data set? So I'm asking you, for which of these data set, either this one or this one, for which data set is the average value of 4, right there, the best representation of the data set? So what would you say? It's like data set 1 is 4 the fairest representation, or is it data set 2? You might want to pause and think about it. The answer is data set 2. This one is the fairest representation of the average of 4. Which data set has more variance from the mean? Well, hopefully you're going to pick this one here, because this has more variance. In other words, the data varies more from the mean in this data set than in this data set. Now that's what we're trying to get at. But what we're going to look at now is, okay, so if this is more varied, data set 1 is more varied, then how do we describe that numerically? And that's what standard deviation is. It's this description of how spread out the data is from the mean. Now let's look at number 2 here. Okay, I'm still with you. I haven't abandoned you yet, so I'm just going to do question 2 in this format. It says it is almost always useful to know how much the data varies from the average. This can be done by calculating the standard deviation. The standard deviation lets us know how much data varies from the mean. How much the data varies from the mean. Which data set do you think varies more? And hopefully you answered this one here, varies more. And when we calculate the standard deviation, we're going to see that the standard deviation of data set number 1 is going to be higher than the standard deviation of data set number 2. Okay, we're going to go through the actual formation of the standard deviation. Well, we're doing it because it actually will explain to you, give you a deeper understanding of it. Okay, so we are going to look at data set 1, which we determined had more variance to it. We're going to calculate the standard deviation. And I'm going to do it by taking the data value. This means the data value minus x bar, which is the mean of the data set. The mean is 4, both of these sets. So I'm just going to write these in here. 2 minus 4, 2 minus 4, 4 minus 4, 6 minus 4, and 6 minus 4. And from here, we just subtract it and get the deviations. So the deviations are -2, -2, 0, 2, and 2. That makes sense, because 2 minus 4 is -2, etc. Now, if I added these up, I would get 0. Which brings us to another point, which about the mean. Let me give you an example. There's 2 numbers, 10 and 15. I want to add one more number. And when I'm done adding it, I want the average of these 3 numbers to be 15. So what I'm going to put here, I want to put 20. And look at the deviations here. The average is 15, so this is a -5, and this is a +5. You add them together, you get 0. So if you add these up, you would get 0. And that's sort of intrinsic in the definition of the mean. But anyhow, so I got these deviations. But the deviations aren't going to do me much good if I add them up, because they're going to get 0. So what we're going to do is square the deviations. That just means taking a -2 and squaring it, which means -2 times -2, or -2 squared, which is 4. So I'm sure you can square these. So that's the square of the deviations. And I had to do it for each one. Now the sum of the squared deviations is our next step, and that is written this way: the sum of the deviations squared, which is the whole numerator of the the standard deviation formula. So I'm just going to add these up: 4, 8, 12, 16. So now why do we square the deviations? Well, we square them so that we can get at, otherwise it's going to be 0, right? The deviations added together will be 0, so I can't add up all the deviations because I'm going to get 0. So if I square them, I get rid of the negatives. Later on, I'll take the square root, which will get me back, which will undo squaring, right? That's why. You get a positive numbers. You get other than 0. So that's the first data set, and that's part of the standard deviation formula right there. So here is our second data set, and I'm just going to run through this really quick. So this is 3 minus 4, 4 minus 4, 4 minus 4, 4 minus 4, and 5 minus 4. So the deviations are -1, 0, 0, 0, 1. Squaring them, 1 times 1 is 1. -1 times -1 is 1. 0 times 0 is 0. And I get the sum of the squared deviations. And for the set that we thought that 4 was the truer value, I only get a sum of the squared deviations, which is this here. That means sum of, we get the number 2. Okay. So now we're going to look at the next little clip. We're going to look at finishing our standard deviation formula. Okay, so we have already calculated the entire numerator of the standard deviation formula. And for the first data set, we got a variance, which is this, the sum of the difference between the data value and the mean. Find that, square it, and then add them all up. And we got 16, and for the second data set, we got 2. Now here's the entire formula for the standard deviation. So I'm putting 16 here and 2 here. Now n means the count, or how many. And for the standard deviation, it's the count minus 1. So there's 5 in the count of each one of them. 5 minus 1 is 4. 16 divided by 4 is 4. And the square root of 4 is 2. And 2 is the standard deviation for data set 1, for the one that we figured had more variance. For data set 2, 2 divided by 4 is 0.5. The square root of 0.5 is 0.707. So we can see the standard deviation measures the average distance from the mean. Does the larger standard deviation in data set 1 confirm your original thoughts that there is more variance in data set 1? The answer should be yes. And if you've got that and you followed that, you should get a smiley face for that. And of course, this one is a little bit okay. So you need to go back a few pages and calculate the standard deviation by hand for the ages of the students in a math class given in example 1. So this is probably one of the few times you'll have to do this, but it should help you to further understand what the standard deviation is. And that page is this one here, and here is your data set that you will calculate the standard deviation. Okay, for the last part here, we're going to look at histograms. And the first is explain the difference between a histogram and a column chart or a bar chart. And this, it's a good little video that explains it in more detail. I'm just going to go over it generally. A couple things with a bar chart or a column chart is that the categories are qualitative. They're groups of things. Like this happens to be chocolate, dark chocolate, milk chocolate, white chocolate, bitter chocolate. And here is the percent that is bought of each type. So 40% by this, 30% by milk, 20% by white chocolate, and 10% by bitter chocolate. So these are qualitative categories. And this is how much of each, and this is in percentage, and this, notice that they're separated. Whereas the histogram here shows the number of cars and the frequency of how many families own how many cars. So this is qualitative information. I'm sorry, quantitative information. Quantitative means numbers. Numbers. So this would say that there one family of the ones surveyed, these are all the ones surveyed, so there was a total, if you add these up, 20 families surveyed. One of those families had 0 cars. 3 of these families had 1 car. 6 of these families had 2 cars, and etc. And now the other difference is that they're slammed together. There's no space between the columns. So that's kind of what the difference is between the two. Now I'm just going to go through these here. And we're going to look at, if I get it focused and in sight there, look at and decide whether these categories are categorical, which is qualitative, or quantitative. Colors of a rainbow. Now, I'm going to either put C for categorical or Q for quantitative. Colors of a rainbow, it's not numbers, it's colors. So it's going to be categorical. Ages of people in a classroom, that's definitely quantitative information because it's numbers. Gender, I think New York City has 24 recognized genders, but they're words, they're categories. Weight of an individual, that's a number, it's quantitative. Jersey numbers of famous basketball players, that's a little tricky one. Well, it's numbers, so it's going to be quantitative. Explain the difference between skewed left, skewed right, and a normal distribution. So we're going to look at that here. Okay, so I kind of start drawing this in. This would be a normal distribution. The data is pretty equally distributed. The mean would be in the middle of the data. That would be X bar here. And the data is, about half the data falls to the left like that, and half the data falls to the right. So it looks like there's just as many, this much above the mean as there is this many below the mean. This is, of course, frequency here. And these are our categories, our quantitative categories. It's a histogram. Now, if you take this and sort of connect all the rectangles and make them smaller and smaller rectangles, you get that, which is a normal distribution curve. Now, being skewed left means that it has a long tail on the left. So that's left skewed. Long tail on the left. Skewed right means it has a long tail on the right. And there's the right. And that's skewed right. We refer to histograms most of the time when we talk about how the data is skewed. And that's because it's quantitative data. Qualitative data, it's hard to skew something towards. For instance, how do you skew something towards bitter? They're just are what they are. Bitter chocolate, white milk, or dark. Okay, so this is going to be our final little thing here. Okay, we're going to start out with this one. It says you sit outside a campus cafe and survey the first 31 people who leave, asking them how many cups of coffee they drink in a day. What does the height of each column represent? Well, the 31 people, if you add up these numbers, 5 plus 8, but plus 10 plus 8, that'll give you 31. So the height, which is also called the frequency, is how many people drank this amount of cups of coffee. So the mode, what's the mode? Well, the mode is not, some students say the mode's 10. The mode's not 10. 10 is the number of people that drank 1 cup of coffee. So the mode is 1 cup of coffee. Now the median, let's drag this up a little bit more. The median here is the one in the middle. And I actually gooped this the first time I did it, but I want to display the data to show this. So here is basically the data, right? 5 people drank 0 cups, 10 people drank 1 cup. Now I'm looking for the middle of this set of data. Well, being that there's an odd number of 31, it's going to be 31 divided by 30 divided by 2 is 15, but you got an extra one. So it's going to be the 16th one. So you could count them out here, and you're going to get right here to the 16th one. That's the one in the middle, which is 2 cups. So that is the median. Now here it says compute the mean. Well, let me put this data set down here. And I could compute the mean from this data set, not from here for now. So how would I do it? 0 plus 0 plus 0 plus 0 plus 0, right? I'm going to add up all these numbers. But I want you to look down here. Here is the value, which is how many cups of coffee. And here's how many drank that number of cups of coffee. So like I wrote here, 5 people. It's the 5 people that drink 0 cups of coffee is right here, the frequency. So instead of doing repeated addition, what I could do is just multiplication, right? Because multiplication, and I'll write that, multiplication is a shortcut for repeated addition. So really all they would have to do is multiply 0 times 5, 1 times 10, and get the numbers here and add those up and divide them by how many? By the frequency, which is 31. So there is the mean right here, 1.87. So instead of going calculating it forever by hand, I'm just going to go down here. This chart here is computing in a step-by-step manner the standard deviation of this set of data, which is related to this frequency distribution. So I'm going to switch over to a hand thing and to the dock camera and just go over these last two questions. Okay, so here's the dock cam for the last two questions. And what they're doing here is building the standard deviation from the formula, one step at a time. A times B is just the value times the frequency, right? Add those up, divide by 31, you get the mean. They want to know what is that negative, how is that negative 1.87 calculated, which is right here. Well, that's the deviation. If you recall, the deviation is the value minus the average. So the value for this row is 0, and the average is 1.87. So it's 0 minus 1.87, and that's how we get our negative 1.87. So the last question here was, how was 7.59 calculated? Well, here's 7.59 right there. How was that calculated? Well, this was calculated by going 1 minus 1.87. So we got a negative 0.87. This is the deviation squared. So this is the deviation, and then they squared the deviation as such. And then they get, how did they get from, that's 0.76. How did they get from 0.76 to 7.59? Because this deviation squared represented one of these number ones. One of these number 1 cups of coffee, but there was actually 10 people that chose that. So they took the deviation squared, multiplied it by 10, and got the total deviation squared for all 10 people that drank 1 cup of coffee. Okay, so I returned for our last little segment here, and no more crackling. My fire went out. That's what I was doing, building a fire. That was that crackling. All right, so here's a scenario. There is houses that were sold, let's say, in Covert, Michigan, or South Haven, Michigan, during a year. So this is the sale price of houses. The sale price. And let's find out what the mean is. So equals the average of all these. So the average sale price was $159,000. And the median, which is what they always use, and this is going to explain why they always use the median house price. If you look anywhere, you'll see median house price. You never see average house price. And this explains why. And so the median is going to be equal to median of this data. So they're pretty similar. Median's a little lower than the mean. Now let's say you come by and there's this house. Oh, I should show you the house. Okay, I'm going to go away and come back. So I'm going to add, I'm going to assume that one of those houses, which it's in South Haven off the Blue Star Highway, one of those homes sold. And so I'm going to add that sale price to the other homes that sold. If I could even get the amount of zeros correct. Yes, $3,200,000. Let's forget the 200. That's about right. That's about what they sell for in that range. Now I'm going to recalculate the mean and the median. By the way, what do you call that? You know the word for that within this data set? It's called an outlier. So let's see what happens to the median first. The median of all these homes. Well, the median was affected. It was affected by $7,000. It went up some, right? Now let's look at the average. Anybody want to take a guess? Did it go up about 10,000? Whoa, it went up over $200,000. So, now you know why they used the median house price, because an outlier can really affect the average, where it doesn't affect the median as much. It just moves the median one. And it's obviously, this data is not sorted, but that's what it does. Well, that's the end of lesson 9. Got my sunglasses.